Good morning to one and all. In the previous class, we discussed about different techniques involved in the stabilization of the soils. But today we have to discuss about these methods and their utilities. In this particular topic, we have to discuss totally 11 methods we are having. In these 11 methods, few methods are repetitive methods. Those methods we have to implement in our national highways and huge amount of projects, so that we have to discuss them very briefly, and few methods are not superior, and we have to know what are the things implemented in those methods. First of all, we have to know those methods. First one is the mechanical stabilization. In this mechanical stabilization, we have to use a huge weight equipment. Simply a mechanical equipment, simply those are rollers and like other stabilizers, mechanical stabilizers we have to use in the site. Next one is the lime stabilization. In this lime stabilization, we have to use simply a calcium oxide or calcium hydroxide. Why? Because calcium is a normally a lime content, so that we need to use those calcium, and we have to bind the properties of soil. That means particle to particle we have to increase binding property, so that we have to go for this kind of stabilizations whenever we are having a less bonding between the particles in the sites. Next one is the cement stabilization. Normally this cement stabilization is used for road networks. That means normally in our areas we have to observe, especially in residential areas, huge amount of road network are associated with these cement roads, so that we have to go for this cement stabilization whenever we are using these cement roads. Next one, chemical stabilization. In these chemical stabilizations, we have to go for different salts and resins to decrease the voids in the soil. Why? Because in a different layer by layer we are having earth, means that means earth we are having different layer by layer. Whenever the construction is over, after the construction is over, we have to observe some quantity of faults. That means mistakes in the construction below the ground level, so that we won't go for densification at that time. Why? Because the total construction is over. In those cases, we have to observe those faulty areas, and we need to use some chemicals to fix those faulty areas and fill those areas, so that this chemical stabilization is useful there. Next one, fly ash, rice crusts, and the bitumen, thermal stabilization, electrical, all those are different kinds. Because those are all waste materials comes from different utilities and industries. Especially fly ash is coming from thermal power plants. Next, rice husk is coming from these rice plants. That means normally rice mills we are having. From the rice mills we are obtaining both rice and this rice husk ash. These rice husk ash normally used in different hotels and others as a fuel for production of heat. After the fuel is burnt, simply we have to obtain some ash in the form of white color in some quantities and black color in some quantities, so that we have to use those for stabilization purpose to decrease the pollution of the environment. Next one, bituminous stabilization. It is also stabilization required for a flexible pavements. Thermal stabilization. These thermal stabilizations are used whenever we are having a content of water or huge amount of moisture in the structure and structural parts. Electrical stabilization also, these are different things. Next, geotextiles. All those geotextiles we have to observe in the upcoming chapters. Separate chapter is for geotextiles and membranes. Next, recycle also we are having different daily utility wastes. That means our utilities means normally we are using different quantities of vehicles, in different size vehicles. Those sizes also we are having tires and other cheap materials. Those we have to use and we have to replace those. First of all, we have to discuss this mechanical soil stabilization method. Why? Because this mechanical means automatically we have to embedded with the systems of this machinery. The mechanical soil stabilization method is the method of improving soil properties by changing its gradation. Normally, grade means a quality. Here, we have to change the gradation of the soil particles. That means simply we are improving the parameters of the soil, whether it may be physical parameters or strength parameters. Why? Because physical parameters means normally a particle size is more, automatically it will absorb water. If the particle size is very less, there may be less content of voids and less quantity of water will be absorbed by the soil, so that its gradation will be very huge. Next one, this method of soil stabilization includes compaction and densification of soil matter by application of mechanical energy using various sorts of rollers, rammers, and vibration techniques. That means rollers. In the second chapter itself, we are observed. That means first chapter itself, we have discussed about rollers. Normally, the work of a roller is to decrease the content of voids and increase the density of the soil. Likely, we are having a rammer. Normally, rammers are a small quantity equipment, so which will be handled by a human with his hands. Normally rammers are having a motor, due to the rotation of the motor, automatically some small loads can be given to the structure, so that the voids will be reduced. Next one, vibration techniques. Whenever the soil is very loose condition, automatically we have to go for these vibrators and vibration techniques. Normally nowadays these rollers also associated with these vibrations. Due to those association of vibration machinery to the roller, automatically our work will be very easier, and in a short span of time we have to complete those works. Next, something like blasting. That means blasting means simply when there is a huge voids, automatically we won't have to go to those contents of voids, then only we have to go for these blasting techniques. After that, those blast area we have to fill with another cheap material which was available on the surroundings. Next one, the stability of the soil is generally depends upon the inherent properties of soil material. Inherent properties means normally whether they may be physical properties or chemical properties or any other structural properties. Depending upon those three elements, the total soil strength will be declared. Why? Because if the physical properties are very less, automatically the strength of the soil also decreases. In case of engineering properties also less, automatically strength will be reduced. So that for each property, whether it may be physical or chemical or engineering properties, all those are associated with the strength of the soil, so that we have to go for these inherent properties of soil materials. In this method, two or more natural soils are mixed together, which is superior to any of its components. That means two or more natural soils. Likely natural soils means what? In our nature we are having different quantities of soils with different chemical contents and different particle sizes and properties, so that some of the soils are having loose properties. That means in case of binding properties or strength properties, some of the soils are having huge amount of strength properties according to their chemical composition, so that we need to improve in a particular land. Automatically we have to mix one with another, and we need to improve the strength of the land, so that from the particular method we need to use more than 2 to 3 quantities of soils, and we have to go for a mixing of these 2 to 3 quantities of soils, then only we will get huge quantity of strength. Next, mechanical stabilization of the soils is done by mixing of blending our soils of 2 or more gradations to obtain a material meeting the required specification. That means here we are mentioning a term required specification. Why? Because normally to a structure. That means whenever we are going to construct a structure, so that the total structure have to be bare by the soil, so that the definitely the soil having higher bearing capacities. Some of the soils having lower bearing capacity and uh, less structural properties, then we have to go for another site. The another site is very much costlier compared than the our sites, so that we have to use those costly money, and we need to go for this densification techniques by using different soil conditions, so that we have to get the project in a very cheap manner. So that these kind of techniques will be useful whenever we are having a huge amount of land in less quantity of strength properties and physical properties. So that definitely we will go for stabilization. Automatically the strength and the properties of soil will be strengthened, and we have to go for our construction in a very low economic contents. Next one, what are the uses? That means whenever we are going for a different techniques, for those particular different techniques we are having some quantities of advantages and some quantities of disadvantages, so that we need to improve the advantages, and we have to go for decrement of those disadvantages by simply applying a different physical parameters and engineering parameters. Likely first use is simplest method of soil stabilization. That means it is very simple to do. Why? Because there is no formulas are there. Simply we have to use these rollers, and we have to roll the land with some quantity of time and weight. Then only we have to get these strength properties. There is no technicians are required, there is no engineers are needed. Why? Because simply it is a rolling mechanism. We have to apply a load mechanism, and we have to roll the roller. Next one, to improve these subgrades of low bearing capacity. That means subgrades. The top level we are having is the main grade. After that top level we are having subgrade and below subgrade, so that whenever we are having a less quantity of strength in our subgrades, so that we have to replace the content of matter whichever is present in the subgrades, and those subgrades we have to densify by this rolling mechanism. Then only we will get improved strength in subgrades by increasing bearing capacity. Next one, extensively used for a construction of bases, sub-bases and surfacing of roads. That means base, sub-base and surfaces. In this particular sentence we are having three quantities of terms. Surfacing of road is the first one. On the surfacing of roads we have to observe vehicles are simply moving, so that the vehicles, whenever the vehicles are moving on the roads, automatically this tire pressure may be exerted to the surface of the road. Okay, so that the surface of the road having huge amount of strength bearing capacity. After that the load will be transferred to base. From the base the load is transferred to sub base, so that on the top part we are having maximum stress content. After that simply to sub base content where there is maybe some decrement of stress. Below the sub base we are having some decrement of stress, so that we need to strengthen the soil by layer by layer, layer by layer in a strengthy manner. Why? Because the stress distribution we have to observe. The stress distribution is that means at what level we are having maximum stress content, so that we, according to those distributions and diagrams, we need to strengthen the soil by using these rolling mechanisms. And by while we are doing these rolling mechanisms we need to face a little bit of difficulties, so that we have to observe those difficulties, and we need to associate those with our engineering principles. Then only we will get a good quantity of strengthened materials and success in our projects. The first properties we have to, factors we have to observe are mechanical strength of the aggregate. Here we are using aggregate. Why? Because the total structure is very weak in condition. Why? Because the total is very fine grained particle. Whenever we are applying a load, automatically the fine grained particle will dispersed into a number of terms, that means number of small particles. The total load was not beared by a soil. In those particular cases, we will go for the stabilization of soil by using these aggregates, whether it may be coarse aggregate or fine aggregate or robo sand, whatever it may be according to the properties of the soil. The first condition we are having is the we need to mix the soil. If the aggregates are very stable, we have to use for go for strength parameters. Why? Because if the soil is in strengthy condition, then only it have to bear the loads. If the soil is very weak, automatically it will not bear the loads, and we have to go for another land. So that we are using here some quantities of aggregates are mixing with existing soil, then only we need to strengthen the soil. If the aggregates used are very high strength, then only we will get maximum content of mechanical strength. However, the mixture is properly designed and compacted, even the aggregates are also relatively low strength can provide a good mechanical stability. That means if the mixture is properly designed, normally the design procedure we have to understand in a engineer, that concrete technology. In concrete technology, we are having M20, M30, M40 like different grades of concrete. For every grade, we are having different strength. Actually, for M20, we will get 28.5 in laboratory conditions and 20 MPa in site conditions. Likely here also we have to go for different design parameters. According to those design parameters, we need to design the layer by layer in a proper mixes, so that we have to replace only 10% of soil and 90% with normal soil. Then only then what kind of strength we are getting. After that, if the strength is not sufficient, we have to improve. It means 15% of another soil and remaining 85% of normal soil. Likely we have to go for different variations. In which condition we are getting maximum strength, we have to observe, and those we have to implement in the site. That means we have to go for different variations of the materials. First of all, in the initial we have to replace with 5% of material. That means the total soil is there, that means the total soil is 100%. From the 100% of the soil, we have to replace with 5% with aggregate. Then what is the strength we are obtaining? Likely after that 5, 10, 15, 20, 25, 30, likely we have to increase whenever we are getting a good quantity of strength. Likely next one is the mineral composition. Whenever we are going for a study, automatically we have to observe these minerals. Why? Because the chemical bond is very much important in strength criteria. Why? Because if the bond formation is very high, automatically we will obtain huge amount of strength. Why? Because now daily we are observing different quantities of rocks. Normally for granite we are having a good quantity of strength, and diamond is also a rock, but diamond is very hard due to its chemical bonds of between carbon to carbon. Likely here also we have to observe the mechanical and mineral composition. Why? Because if the mineral content in our soil is very much high, automatically the soil is having huge amount of strength compared to normal soil. Mechanical stability of mixed soil depends upon the composition of the minerals. That means what quantity of minerals are present in our existing land, so that is those are sufficient for our strength criteria, or we need to replace with another quantity of minerals. Those also we have to study. Next one, factors affecting the mechanical stabilization. That means different factors are there. How those factors will affect the stabilization criteria. First of all, in the previous study we have discussed two things: mechanical strength and mineral composition. In this third case, we have to go for this gradation. Normally grading means whenever we are going for gradation, automatically the first we have to get very strength, after that we have to go for a medium, after that very coarse. Likely we have to obtain different quantities of materials according to their parameters. The gradation of the mixed soil should be such that the voids of the coarser particles are filled with finer particles to obtain high density. In this particular sentence, we have to observe a specific thing. The gradation of the mixed soil should be such that voids of coarser particles, that means if our soil is having huge amount of voids, we need to choose very fine matter. Why? Because the fine matter will having a tendency to fill the gaps, so that if the existing soil is very, that means very bulk in property, that means very bulk means size of the particles are very high, then only we have to go for very fine particles and we have to mix in a very huge manner. That means we have to mix those materials in a very plenty times. That means a number of times we have to go for mixing. Why? Because the existing soil having huge amount of void, so that whenever we are adding another material from another land, automatically those material will have a binding capacity with the surrounding soil, then only we will get a good strength parameter. Next one, physical characteristics. After that, physical, mechanical and gradation is over. Next we have to go for plasticity characteristics. First of all, the plasticity characteristics means this plasticity index we have observed in engineering, that geotechnical engineering. In the geotechnical engineering, we have this plasticity index experiment. In this particular experiment, we have to add some 2 to 3% of water to the soil. After that, we have to go for well mixing. Mixing is over, we need to do some thread like matter. After that, we have to go for simply converting those thread into a smaller diameter line. Whenever the thread becomes breaks, automatically we have to observe what is the diameter of that particular thread, so that we will get this plasticity index. Likely here also we need to have this plasticity characteristics by adding some quantities of different materials from another lands. First of all, for mud road surfacing, that means normally in villages we are observing these mud roads. Why? Because the vehicular movement is very low in the villages, then only we are getting these mud roads. Why? Because those mud roads are very cheap in construction, so that simply we are preferring high plasticity soils are used to binders. They possess greater cohesion, moisture retention capacity and provides sealing. Here we are having a binding property. Normally soils are different, soils having different binding properties, so that whenever we are going for constructing a mud road, automatically we have to choose a better binding material. Why? Because those soils have to be have to take huge amount of loads whenever the vehicles are moving, so that a binding property is very good. Automatically those soils will bear huge amount of loads and withstand for a large span of time. Next one, greater cohesion. Also cohesion means automatically if the water is entering into the soil in rainy seasons, we have to observe the cohesion properties and moisture retention capacity also, so that if the voids are very high, water will be stagnant. If the voids are very low, automatically the water will be drained into another soils or surrounding soils. And we need to provide a seal. That means on the top part of the road we have to provide some seals by simply using these fabrics and other plasticity properties of different agents, like chemical agents or others. Next one, against downward movement of the surface water for base courses, the soil should have low plasticity and avoid excessive accumulation of water and the resulting loss of strength. First one is the against downward movement. Why? Because downward movement means automatically in our hill villages and other parts of our here country, that we are having a huge amount of rocky strata. Due to this rocky strata, whenever there is a rain condition, automatically the water will be flowing from high altitude to low altitude, and there will be staggered on the road surface. In those conditions, the total road surface will absorb the water, and those water will be distributed to base courses and sub-base courses. Then we have a decrement of the property of the soil due to its plasticity property, and we need to avoid those conditions simply by constructing a small embankment. That means on the top layer of the road we have to give a circular shape, then only the water will be drained easily and there will be less quantity of absorption to the road surface. Next one is that the soil available at a site may be seldom to meet with the both requirements of the necessary to mix soils with the different sources to obtain a desired mix. This is the previously we discussed, so that we have to use different quantities of materials for obtaining a good strength materials by simply mixing with one or two soils. That means we need to collect some quantity of material from one soil and another quantity of material from another soil, and we need to mix those three matters in a well grading mix, then only we will get the strength. Next one, these mechanical stabilizations we are having. Up to till now we are discussing about these mechanical stabilizations. Okay, these are the different factors and uses for those mechanical stabilizations. After the mechanical stabilization is over, we are having this physical stabilization. In this physical stabilization we are having different quantities. Those first one is the lime, cement, bitumen, chemical and resin. All those are the binding properties, so that those are called as a physical stabilization parameters. In this particular techniques, more than 2 to 3 soils are blended to improve physical properties of a weak soil. In the previous case also, that means mechanical stabilization, we are using 2 to 3 quantities of soils and simply we are mixing. After the mixing is over, simply we are compacting by the help of rollers. But in case of here physical stabilization, we are using 2 to 3 quantities of soil. In addition to those soils, we are using an extra quantity of materials in the form of this lime or cement or bitumen or chemical or any other epoxy resins. Why? Because those are having huge quantity of bonding property. Why? Because all those are simply chemical matters. Lime is a chemical matter which is having calcium content. Like cement also we are having calcium content and silica content. Next one, bitumen. In this bitumen we are having carbon content. Next one, chemical stabilization. Different chemicals we are having different magnesium, potassium and sodium contents. Next one, resins. Automatically these resins are very bonding agents, so that they will fill the voids in any structural parts. So that all those are physical stabilization, all those properties comes under this physical stabilization, so that we need to avoid the that means weakened soils, and we need to get a strong soil by adding all these chemical matters. First of all, we have to go for this lime soil stabilization method. In this particular lime soil stabilization method, what we are having is the soil stabilization method, which is added to soil to improve properties of known. That means we are simply adding a lime as a additive material to the soil, so that this stabilization we are call it as a lime stabilization. Normally lime is also having different categories. And how we have to get this lime? Lime is produced by burning a limestone. Limestone is a naturally occurring resource, so that we have to get those limestone and we need to burn in the clay and kilns. That means burn in the kilns, not clay. Clay is also a matter like limestone. We have to burn those limestone in kilns. One kiln అంటే బట్టీలు అంటాం, ఇటుక బట్టీలు అలాంటివి. In those particular kilns we have to heat the lime up to 1000 degrees or 800 degrees depending upon the grade of the lime. In this lime also we are having different grades. Why? Because if there are impurities in the lime, automatically the grade will be decreases. If there is no impurity, it is a pure lime. If there is a impurity, means automatically it will be converted as a class A, class B, class C, class D according to its impurity content. If there is 5% impurity, automatically class A, 10% class B, 15% class C. Likely there may be another classification according to the presence of impurities in the lime, so that whenever we are doing a good project, automatically we will have to go for a good quality of these stabilizations by using a pure elements. Why? Because the total structure life depends upon these materials. The quality of lime obtained depends upon the parent materials and its production process. Normally parent material means the raw material where we have drawn from the land, and the next one is the production process. While we are heating, automatically due to this heat, some quantity of carbon dioxide or any other vessels having some impurities, those are also having a tendency to mix with the lime, and those will cause some changes in the limestone, so that we have to go for a pure limestone. And the method also we have to observe in a naked eyes. Basically different types of limes we are having according to their impurities, as previously we discussed. Those limes we have to observe. First one is the high calcium or quick lime. That means in this lime we are having only calcium content and oxygen content, there is no impurities, so that it is a high calcium and quick lime. Why? Because only calcium content is there, Ca plus 2, so that it will react with the surrounding particles and will bind easily. Second thing we are having is hydrated and high calcium lime. That means hydrated means simply whenever we are added water to the matter, automatically it will be hydrated matter. So that previous case we are having CaO, we need to add H2O to CaO, CaO plus H2O, simply they will becomes CaOH twice. Next one is the dolomite lime. Normally dolomite is the material which having magnesium content. Here also we are having magnesium. That means some quantity of impurity in the form of magnesium is there, so that it is simply called as a dolomite lime. So that chemical composition is CaO plus MgO. Next one, normal hydrated or dolomite lime, so that CaOH twice plus MgO. Next one, pressure hydrated dolomite lime. That means pressure hydrated means automatically both these CaO content and magnesium content are hydrated, CaOH twice plus MgOH twice. So that we have to observe those two things. In this lime process only we are having calcium content and oxygen content. If there is hydrated, automatically we are getting hydrogen content. If there it is a dolomite means automatically magnesium content is also present. Simply on the first scale we are having quick lime, it is having good binding properties. Simply at the bottom we are having calcium hydroxide and magnesium hydroxide, it is very weak compared to a quick lime. Next one, how we have to go for these lime stabilizations. Why? Because whenever we are choosing a particular method, we have to observe what are the advantages and what are the disadvantages. In this particular case, the major advantage is lime is a cheaply occurring material. That means the cost of the lime is very much low compared to other chemical sources present in the earth. So that we have to, many of the stabilization methods we are using lime. It is very cheap cost, that means low cost compared to other binding materials. Lime stabilization is the one of the cheapest soil stabilization method among those. Why? Because there are different types of limes like hydrated lime, calcium lime, monohydrated lime, dolomite, quick lime, dolomite lime. About all those are previously we discussed. The most of the soil stabilization is in the range of 5 to 10%. That means if we are taking, I have to show with the diagram. If this is the total surface, we need to, that means it is the total surface. For this particular surface we are having breadth and this depth, B value, D value. breadth, depth, and automatically we are having area. In those three cases we have to calculate the volume. Breadth, depth, and this another height parameters, so that by multiplying those three b, d, h, we will get the volume. From those volume we have to take only a 5 to 10%. Normally for every volume there may be some quantity of density, so that if it is a 1 meter square, the 1 meter cube volume, automatically from those 1 meter cube volume we have to use only a 0.0005 meter cubes of this lime, and we have to mix those with the soil in a regular manner. It means we have to use those lime and this soil mass in a very that means very fine content we have to take, and those we have to mix in a well graded manner. Then only there will be a bond formation. After that we have to go for rolling, then the strength and the soil we will get. And next one is the stabilization method improves the properties by increasing the strength by cation exchange. Here we have to show the cation. Normally Ca plus 2 plus O minus 2. These are the cations and anions. Here positive symbol means cation, negative symbol means anion. Whenever this is the normal lime, so that we have to, they will disperse into Ca plus 2 and O minus 2, cation and anion. Then Ca plus 2 will react with the surrounding two molecules, and O minus 2 also react with surrounding two molecules. They will simply form bond between the surrounding soil elements. Then if the bond is very tight, automatically we will get a good compressive strength and soil bearing capacities. Lime stabilization is also indicated by the pozzolanic reaction in the form of pozzolana materials react with lime in the presence of water to produce cementitious products. In the previous case also we have observed lime and hydrated lime. The difference between the lime and hydrated lime is simply H2O. Whenever we are inducing some quantity of water to the lime, the total lime will be converting into hydrated lime. Those are also we have to bind with the soil and we have to mix in a graded manner. Then only we have to go for this rolling and strengthening parameters. I am having some quantities of images. I will show those images. Then we will get a brief knowledge how we have to mix the lime and in what way we have to roll. All those we are having diagram and pictorial representations. After that, lime stabilization method is most widely utilized in geotechnical and environmental applications. That means geotechnical means in the case of soil, environmental means in the case of water. That means normally water is also having different pollutions according to this algae and flora fauna. We are having those contents due to those algae content and flora content in the water, we have to get a bad smell. To arrest those bad smells, simply we have to go for this induction of lime in the water sources. Then those bad algae will be disappears. It has some important applications like encapsulation of contaminants or highway slope stabilizations, rendering backfill and foundation improvements. Why? Because encapsulation and contaminants highway in the soil itself we are having different contaminants. Those will contaminate simply converting the soil matter into organic or peat matter, so that those organic peat matter will improve as a tree or any other vegetative matter, so that whenever the organic matter is converting into vegetative matter, the total strength of the particular quantity of area will be decreases. To arrest those conversion of normal matter into organic matter, simply we have to use some lime. Due to those lime also, the total organic matter will be disappears and the reaction will be gone. In different areas we are using highway areas. That means highway means if there is vegetation, automatically cracks will be appear to the total road surface, so that we have to arrest those cracks simply by introducing some lime to the soil. Next one, slope stabilization. In this slope also, whenever there is a slope, automatically the soil have to be eroded due to this wind, water and other temperature effects, so that we have to get strength by adding this lime to the slopy areas. Next one, backfills also we are having same phenomena, and foundation improvement. In the foundation also we have to bond the foundation matter with surrounding soil particles. However, any existing sulfur or organic materials may be inhibit the lime stabilization process, so that generally it reacts with lime and swell maybe have an effect of soil strength. That means if there is any existing chemical contents, then we have to observe what is the exact chemical composition of our land, so that is there any disadvantages materials are there, so that we have to observe, and then only we will go for this stabilization. Why? Because if there is any disadvantageous materials, automatically those materials will form a bond with calcium, and those calcium will be in the stage of unreaction state, so that in those particular state the calcium adding is also not suitable for strengthening properties. So that while we are going for this kind of techniques, we have to go for chemical analysis of our surrounding soils. These are the different limes. Quick lime is more affected compared to hydrated lime. And next one, higher the magnesium content on the lime, less is the affinity of the water, less is the heat generated due to mixing. Why? Because normally a pure form of lime there is a rich content of calcium, so that calcium is very rich, automatically heat also very high, so that in some of the cases we are using these slaked limes, like slaked limes means automatically calcium is associated with this content of magnesium, then only they will be called as a slaked limes. In those particular slaked lime conditions we are getting less quantity of heat production. Why? Because if the total process is involving with humans, automatically their hands will have to suffer, their body have to be face different problems due to this heat of hydration, so that we need to add some quantities of impurities in the form of magnesium. Magnesium will not decrease the strength, but it reduces the production of heat. Next one is the amount of lime required for varies between 2 to 10% of the soil, so that on the total volume of the soil we have to take from a minimum content of 2% and maximum content of 10%. Those limits we don't have to cross. This is also the properties. Lime stabilization is done by adding lime to the soil, useful in mostly for clayey soils. Why? Because clayey soils are very weak and fine, so that whenever we are adding this lime, automatically those clay will be strengthened. And lime reacts with the soil, and exchange of cations absorb the water and decreases the plasticity of the soil occurs. Next one, it results the materials is more friable than the original clay, is therefore more suitable as a subgrade. This is the process how they have to use this lime for stabilization. Normally here we are having a mixing equipment. Normally this equipment will spread the total content of lime on the soil, and after that simply it moves, it will mixes in a equivalent manner, so that the total lime will be mixing with the surrounding soil in a very easy manner. This is the another kind of method for spreading the lime in the soils. In this particular method, the total lime is spreaded in a row-like mechanism, but in case of previous, the total lime is spreaded as a sheet-like mechanism. Sheet means simply as a thin layer they are spreading, but in case of here, they simply spreaded as a line-like mechanism, lines. Here also, before spreading of lime, how the total soil behavior. After the spreading of lime, the total will behave as a very smooth manner with some quantity of binding properties without absorbing water. But in the previous case, the total soil is in having huge much amount of water, and there may be some sinking of these vehicles. That means totally those are construction equipments, those are also sinking in the soils before
lime. After the lime, the total equipments will be moving in a easy manner. Here also it is another mechanism. Why? Because here we are having some quantities of rolling. Those will mix the lime with the soil in a easy manner. Here also we are having another equipment. All those equipments we have to observe in construction technology and management subject. In this construction technology and management, we are having different equipments used for the construction process. Those will decrease the life, that means decrease the time and increase the lifespan of the roads and other structures. Here also simply they are spreading water which is also associated with this lime, so that there may be some penetration of lime with the surrounding layers. They will get the strength and bond as well as. Okay, up to this we have completed the stabilization of soil with content of lime.